Let's review factoring trinomials. Trinomials means 3 terms. If we have 3 terms, we can still try a greatest common factor. Or there's another method for something that only works for 3 terms, and that is reverse FOILing. It is where you multiply to be the last number and add up to be the coefficient of the second number. Let's label that throughout here. We want to multiply to be the last number, add up to be the coefficient of the second number, multiply to be the last term, add up to be the coefficient of the second term, multiply to be the last term, add up to be the coefficient of the second term. By writing this down and saying it over and over again, we are just training our brains to recognize that pattern. And I'm going to start with the ones that actually end with a negative coefficient. So I'm looking at letter B and letter C. These both end with a negative number, which I think is easier because then I know what type of factors I have. So looking at letter B, I have x's getting multiplied to be x squared. And since I end with a negative number, there's only one possible type of factor, right? If I had a positive times a positive, what would that be? It would be positive. If I have a negative number times a negative number, that's also positive. And we're trying to multiply to be a negative, which means I have to have a positive times a negative. So I like these ones that end with a negative because I know what type of factors I have automatically. A positive times a negative will multiply to be that -4, just like I need it to. So I'm going to multiply to be a -4, and I want factors that have a difference of +3. So I'm thinking of factors of 4. One could be 2 times -2 would be -4, but those don't differ by 3. 2 minus -2, that's not going to work. So other factors of 4 could be 4 and 1, and 4 and 1 do differ by 3. 4 minus 1, it differs by 3 away. So I want to add up to be a +3 though, so the bigger number must be the positive one. So 4 minus 1 gives me 3, and 4 times -1 gives me that -4. So I could multiply this back and check it. It does work out. We need x plus 4 times x minus 1. Let's look at the other one that ends in a negative. And we want to multiply to be a -63. Automatically, I have to have a positive times a negative to multiply to be a negative. I want factors of 63 that differ by 2. So 63 minus 1, those differ by 62. 63 times 1 works to be 63, but those two factors differ by 62. That's way too big. I want to just differ by 2. So I want to think about other factors of 63, or grab my calculator and start dividing 63 by some numbers to see which two numbers differ by 2. And it is 7 times 9. Now, which one's going to be the positive one? It has to be the bigger one so that I can add up to be a +2. So I'm going to do +9 minus 7 is 2, and 9 times -7 is -63. If I did it the other way, if I switched the signs and I did a +7 minus 9, I'd add up to be a -2 instead of a +2, so it wouldn't be correct. Before we look at ones that end with a positive number, I've written in an extra example here that is the same type. Which one is the extra example that it's the same type we just did? The x squared minus 6x minus 40, or the x squared plus 8x plus 15? It's got to be this extra example here, the one that ends with a negative number. Tells me I have a positive factor times a negative factor in order to multiply to be a negative number. I want factors of 40 that differ by 6. So I can't use 40 times 1 because 40 minus 1 is going to be 39. Other factors of 40 could be what? We're going to have 10 times 4 gives me 40, and then 10 minus 4, those differ by 6. I want to make sure I put the correct sign on each number. I want to add up to be a -6. So the bigger factor must be the -1. So -10 plus 4 is -6, and 4 times -10 gives me that -40 that I need. So there's 3 examples of ending in a negative. Let's switch and end in a positive number now and see how that differs. So for this first one, we end with a +9. Ending with a plus is a little bit harder because there's two ways to multiply to be a positive. It could either be two positives multiply to be a positive or two negatives multiply to be a positive as well. So I want to add up to be a -6 though. So is that going to be two positive numbers can add up to be a negative number, or two negative numbers add up to be a negative number? It has to be two negatives, and I want to think of factors of 9. So 9 and 1 are factors of 9, but -9 minus 1 is going to be -10. So I need other factors of 9. I'm going to have -3 minus 3 is -6, and -3 times -3 is a +9. Let's try that again with some new numbers. For letter D here, we want to add up to be a -8 and multiply to be a +12. So to multiply to be a +12, I can have two positives or two negatives. Well, which type is going to add up to be that -8? Two positives are not going to add up to be a negative, so it must be two negative factors. And I want factors of 12, so 12 and 1 would multiply to be 12. But 12 minus 1, -12 minus 1 is going to be a -13. That's not going to work. So other factors of 12, if I try -4 times -3, that would be -12, or +12. But -4 minus 3 is going to be -7. So other factors, I need -6 minus 2 gives me -8, and -6 times -2 is +12. Lastly, let's fill out this last extra example. We want to multiply to be a +15 and add up to be a +8. So to multiply to be a +15, I either have two positives or two negatives, but I want to add up to be a positive now. So I must have two positive factors. We'll multiply to be positive and add up to be positive. 15 times 1 is 15, but 15 plus 1 is 16, so that doesn't work. Other factors of 15, 5 times 3 is 15, and 5 plus 3 is 8. So this is called reverse FOILing. I can always try greatest common factor, but if not, if we have three terms, we can do this reverse FOILing. That last term tells us the type of factors we have, whether it's two positives, two negatives, or a positive times a negative. That's all decided by the sign of the last factor and then looking at what the second factor is.